Hello, hello. Morning.
Morning.
Okay, let's continue. Okay, yeah. So, last week we were up to biology unit 7, human nutrition. Okay, so we will continue with that. Okay, yeah. Okay, we were up to here. Okay, yeah, question 2. Okay, so this question is very straightforward. Figure 7.6 show the 4 types of teeth found in humans. Okay, so what we need to do, copy the figure and label one example of each of the 4 types of teeth. Okay, yeah. Okay. So this is straightforward. We just need to refer to the notes. Okay, yeah. So it should be like this. Okay, so if we focus here, okay, 4 types of teeth. Okay. Incisors, canine, premolars, molars. Okay, so if we see here, the front four, four teeth will be incisor, and then on the side will be canine. Yeah, so 2 of them, and then premolar, 4, 1, 2, 3, 4. Okay, uh, yep, and then the rest, okay, will be molars. Okay, so this one will be molars. Yeah. Okay. So we just need to remember the position and then know how to label them. Okay. Next. Okay. What is the function of teeth label A? Okay. So A will be incisors. Okay. So incisors the function. Okay. Incisors is for biting or cutting food. Okay. No problem. Okay, function that is labeled B. Okay, so B will be molars. Okay. Okay, function of molars. Okay, we remember that. Okay, for chewing, grinding, or crushing of food. Okay, next. The outer layer of the crown of a tooth is resistant to attack by bacteria. Name this outer layer. Okay, so we can refer to the notes quickly. So what is that? Okay. Okay. Okay, outer layer. Yeah, this one. Okay. So outer layer is the enamel. Okay. So enamel is resistant. Okay. Resistant to attack by bacteria. Name this outer layer. Okay. So the outer layer is enamel. Okay. So what we mentioned before. State the mineral and vitamin needed in a diet for the healthy development for this layer. Okay. So what is it made out of? The enamel. It is made out of, okay, calcium and vitamin D. Okay. So these two are needed to have healthy teeth. Okay. Next. Okay. So here we have analysis of 4 food samples. Okay. So we'll take a look. Okay. So we have different colors. Okay, so blue is water. Okay, green is fiber. Okay, yellow is fat. Red is carbohydrate. Protein is purple. Okay, so for example, meat. Okay, so meat we have quite a high percentage of water. So from around like maybe like 33 to 100% is water. Okay. And then maybe like 18 to 33 is carbohydrate, and then 0 to 18 is protein, and so on. Okay. And then for the whitefish, so we can see a lot of water as well, and then a little bit of carbohydrate, and then quite a bit of protein. And then wholemeal bread, okay, is less water, okay, have some fiber, lots of carbohydrates, and a little bit of the fat, okay, so yellow is the fat, and a little bit of protein. Baked beans, again, lots of water, okay, some fiber, and then lots of carbohydrate and a little bit of protein. Okay, so roughly we get some ideas there. Okay, next, which food contains the most protein? Yeah, so we can see that the one that has the most protein. Okay. Um, yes. The one that has the most protein we can see is the meat. Okay. So it's the highest amount of protein. Okay. Yes. Okay, next. Most carbohydrate is very clear. The one that has most carbohydrate will be the um wholemeal bread. Okay. Yep. Okay. Yeah. Wholemeal bread. Okay. Next. Most water. The one that has the most water. We can see that it is the whitefish. Yep. Okay. And then the one that has least fat. Okay. So least fat, our answer should be baked beans. Yeah, baked beans. Because we see it got zero fat. Okay. No fat there. Okay. Okay, next. Suggest why meat contain no fiber. Okay. So we can see here the meat, okay, it got no fiber. Okay. So the reason, because the meat is made of animal cells which do not have cell wall. Okay. So fiber is coming from the cell wall. Okay. Explain why fiber is important in a balanced diet. Okay. So why fiber is important? We know that. Okay. It adds bulk to undigested food, maintains peristalsis, so the movement of the food in the intestine, and then it prevents constipation. Okay. Next, where is water absorbed in the digestive system? Okay, so we already learned that it is in the ileum and colon. Okay, small intestine and large intestine. We will reabsorb the water. Okay, next. The graph does not contain data about all the components of the balanced diet. Which components are missing? Okay, so we have water, fiber, fat, carbohydrate, and protein. So we are missing. Okay, what is it we are missing? We are missing minerals and vitamins. Okay, so it's not shown because the amounts are too small. Okay, okay, next. Okay, name the part of the digestive system is responsible for each of these function. Yeah, so we need to remember the function. Okay, so first one, moving food from mouth to the stomach. Okay, so we know that. A okay, moving food from mouth to the stomach will be the um esophagus. Okay, yes. Yep. producing bulk. Okay, so producing bulk will be the liver. Okay, so liver responsible for producing bulk. Okay, storing feces. Okay, so where we store the feces is at the rectum. Okay, so that's where we store the feces. Okay, next, digesting starch. Okay, so where it happened, digesting starch. Okay, so it happened at two main places. It happened at the mouth. Okay, salivary amylase. Okay, and in the small intestine. Okay, so small intestine, pancreatic juice. Okay, so producing the pancreatic juice, which um digests the starch. Okay, so our answer: mouth and small intestine, or duodenum, or ileum. Okay, absorbing water, where it happened, in the ileum and colon, small intestine and large intestine. Physical digestion, okay, just breaking into small pieces. Okay, a few places. Okay, the teeth and the stomach. Okay, okay, secreting three different enzymes. Okay, we know that it is the pancreas. Okay, so pancreas will secrete the pancreatic juice. Okay, yep. Okay, so with this, we finish. Okay, so we finish all of the notes. Okay, for this unit 7. Okay, human nutrition. Okay, so everything finished. Okay, so now we will move on to the workbook. Yeah, okay, so let's take a look. Okay, so name the nutrient that is responsible for each of the following symptoms when in short supply. Okay, yep. So we already learned the different nutrients. Okay, yeah, and the deficiency disease that can happen um if we are lack of these nutrients. Okay, so first, soft bone and teeth, okay, is due to short of the calcium. Okay, yes, it causes the rickets. Okay, calcium or vitamin D. Dehydration because we lack of water. Constipation because we lack of fiber. And scurvy is due to deficiency of vitamin C. Okay, yeah, straightforward. Okay, next, a teenager ate the same main meal each day, a hamburger in a white bread bun with chips and a glass of cola. Okay, table show the nutritional value of the food eaten. Okay, so we have four um four types of food in his lunch. Okay. Um, okay, same main meal each day. Okay. With reference to the nutritional data, state two nutritional advantage and two disadvantage of eating this meal. Okay. Yep. So what can we say about this meal? The content. Okay. What is good about it and then what is not good about it? Okay. We can think about that. Okay. First, advantage. Okay. So we'll take a look at the advantage. Okay, advantage, high carbohydrate level. So we can see the carbohydrate amount is a lot. Okay, so it produces lots of energy. Okay, so calcium also present. It's a good source of calcium for strong bones and teeth to prevent rickets. Okay, and then protein is present. Okay, So protein is also present. Okay, this is good for growth and repair. Okay, what's the problem? Okay, with this diet here? Okay, disadvantage. Okay, high animal fat. Okay, so we can see high animal fat. So which especially in the chips, okay, so which can cause heart disease, atherosclerosis, obesity. Okay, yeah, so can cause our blood vessels to be blocked. Okay, lack of fresh fruit and vegetables. So we can see that there's basically no vegetables, okay, and fruits. So this fresh fruit and vegetable will give us fiber to prevent constipation. Okay. Um. Okay. Three foods contain no vitamin C. Okay. So we can see here only chips have vitamin C. Okay. So which means we are very low on vitamin C. Vitamin C is important to prevent scurvy. Okay. And then another problem, iron level is low. Okay, so we can see here iron compared to calcium is very, very low. Okay, so iron is very important for our blood. Okay, so if we are lack of carbon, we will get anemia, which is a lack of blood in our body. Okay, so this is how we can analyze the table to discuss. Okay, to comment on a diet whether it's good or not. Okay. Okay, next. Suggest two long-term effects of continuing eating this meal regularly. Okay. So if we continue this meal with these advantages and disadvantages, what could be the long-term effects? Okay. So he might get constipation because lack of fiber, okay, in this diet, and then risk of obesity, scurvy, and anemia. Okay, risk of obesity because high amount of fats. Okay, high animal fat. Scurvy because lack of vitamin C. Anemia because lack of iron. Okay, risk of heart disease or atherosclerosis. This is because of the high amount of animal fat. Okay, so we can make some conclusion from our discussion here. Okay, next. Okay, this diet could be described as unbalanced. Okay, so what it means by balanced diet, making two key points. Okay, so unbalanced means we are lacking something. Okay, or the amount is too much. Okay, so what's balanced diet? A diet that contains all the main nutrients in the correct amount and proportions. Okay, so not only we need to have everything, but the correct amount and proportion is very important. Like the fats cannot be too much. Okay, so state one food group missing from the diet in the table. The one that is totally missing is fiber. Okay, so we don't see any category of fiber in the table. Okay. Okay, next. The diagram of digestive system. Name parts A to H. Okay. So name the parts A to H. Okay. So we just need to remember. Okay. The label of all the different parts. Okay. Uh, yep. Okay. So just need to so this part need to memorize for the exam. Okay. Yep. Okay. So if we refer this picture here. Okay. Yep. So very straightforward. So we can see A is the mouth. Okay. So B, esophagus. Okay. C is the stomach. Okay. D, the large intestine. okay, or colon. E is the rectum. Yeah, okay. Okay. Next, okay. H here, we can see where it's pointing. It's pointing at the duodenum. G is pointing at the ileum. And F is the anus. Okay? Yeah, straightforward. Okay, next. Okay, complete the table to compare the type of human tooth. Okay. Oh, yeah. Okay. Hold on. Okay. Okay, let me open again. Okay. Um, hmm, okay. Yeah, I forgot something, but it's okay. Yes. So what I forgot here is I forgot to label. This one is will be canine. Okay, and then this one will be molar. Okay. Hold on. Okay. Okay, let us continue. Yep. So, four types of teeth. Okay. Okay, so we did have the label just now. Okay. Yep. Okay, let's take a look. Okay, so we remember that. Okay, so four type of teeth. Okay. Okay, so first one, incisors. Okay, so what's the description for the incisors? Okay, chisel shape. Okay, the shape is like a chisel. Okay, so it's quite sharp. Function, biting off pieces of food. Okay, next. Next one will be canine. Okay, so canine, slightly more pointed than incisors. Okay, and then function, same thing, biting off pieces of wood. Next, premolar. Okay, this one. Okay, premolar, the shape. Okay, 2 points cast. Okay, so we can see it, 2 points, one or two roots. Yeah, one or two roots. Okay, function, tearing and grinding food. Okay, next. Okay, molar. Okay, 4 or 5 cups. Okay, the top there. Okay, and 2 or 3 roots here. Okay, so the function is similar, chewing and grinding of food. Okay, next. Define the term chemical digestion, making 2 key points. Okay, so we remember that. Okay, difference between chemical and physical digestion. Yes. Okay. Okay, physical and chemical digestion. Yep. So main point, physical digestion is still the same substance. Okay, like it is still starch. It's just um being crushed and grinded or torn. Okay, breaking into small pieces. Okay, it's still the same substance. Chemical digestion, we produce a new substance. For example, starch is turned to glucose. Yeah, so that is a change of properties. It happens in the presence of enzyme. Yeah, okay. So different enzymes. Okay, so chemical digestion. Okay, what it means by that. Okay. Yep. Okay, so breakdown of large insoluble molecules into small soluble molecules. Okay, complete the table by stating, okay, yeah. So we need to complete this table. So amylase enzyme, where is it secreted? The substrate the enzyme act on, and the products. Okay. Yeah, so we already learned that. Okay. Yes. So means this table we need to memorize. Okay. So for the exam. Okay, so amylase, what does it do? Okay. And the products. Okay. Okay, so we have all the information here. So this is straightforward. Okay. So this is the kind of questions that can come up in the exam. Okay, which is not very hard. Okay, if we remember everything. Okay, so amylase. So where we found in the mouth and duodenum. Okay, so the substrate, what it is breaking down, starch. Okay, the products will be maltose or glucose. Okay, next lipase. Okay, so lipase, the function is for breaking down fats and oils. Okay. Okay, where we can find it. Okay, so it's secreted to the duodenum. Okay. Where is the duodenum? Yeah, here. Okay, with the start of the small intestine. Okay, so duodenum. Okay, so for breaking down of fats and lipids. Okay, so breaking down of fats and lipids will produce. Okay, so what it will produce? Ah, yes. Okay, breaking down of the fats will produce glycerol and fatty acids. Okay, one molecule of glycerol, three molecules of fatty acids. Okay, yeah, and then protease. Okay, so protease is for breaking down of protein. Okay, so present in stomach and both duodenum and ileum. Okay, for breakdown of protein to produce amino acids or peptides. Okay, so we already learned that. Okay, yes. Yes, protein. Okay, so we start with the long protein chain with pepsin break down into small chains like this. Okay, and then with trypsin break down into dipeptide, just unit of two. And then finally, erepsin break down into individual amino acids. Okay. Yep. So it's not difficult. Okay. Outline the role of bile in the digestive system for physical digestion and chemical digestion. Make two key points for each type of digestion. Okay. So we know that for the bile, yes. Okay. So this is the function here. Okay. So the function of the bile. Okay. So we can see here. Hold on. Okay, so we have this large droplet. Okay, let me show. Uh, yes. Okay, so the row of bar. So we have these large fat droplets. Okay, so when it come into contact with bile, it will turn into small fat droplets like this. Okay, which will increase the surface area for digestion. Okay, so that's the function. Okay. So for physical digestion, what we mentioned just now, the bile will emulsify the fats breaking them into smaller droplets with a large surface area. Okay, so this is physical digestion. For chemical digestion, the bile is slightly alkaline. So the enzyme in the small intestine will work best in alkaline conditions. And then also bile contain sodium hydrogen carbonate, which neutralize acid from the stomach. Okay, so these are the main points. Okay, so we see here, this is a 4-point question. Okay, so 4-point question, which means we need just any two. Okay, but in the exam, we normally try to write extra just in case. Okay, but minimum 2 will be enough. Okay, next. Describe the function of two named type of tooth in the physical breakdown of food. Okay, so okay, here. Okay, so we can just choose any two type of teeth. Okay, and talk about the function. Okay. Okay, first, so we can choose anyone. Okay, so incisor for biting off pieces of food. Okay, canine, biting off pieces of food. Premolar, okay, tearing or grinding of food. Molar, chewing or grinding. Okay, so any two will be enough. Okay, next. Okay, so here we need to label the human tooth. Okay, so this is straightforward. Okay, yes. Okay, yes. So we just need to remember this. Okay, so you can see the questions are not difficult. Okay, yep. Okay, so we can see here. So A, okay, A is here. So is the enamel. Okay, okay, B is here, dentine. Okay, C is inside. Okay, so this is the pulp cavity. Okay, D is here. Okay, is the gum. Okay, E is this outside layer here. Okay, is what we call cements. Okay, cement. Okay, so F. Okay, so okay, how about F? Oh yeah. Okay, so F is not mentioned here clearly. Okay, so the gum will be the tissue, under the gum will be the bones. Okay, so this is the jaw bones. Okay, G. G is this one, nerves. Okay, okay, next. State the type of tooth shown and explain your answer. Okay, so what type of teeth is this? Okay, so our answer will be so it could be, if we take a look, it could be premolar or molar. Okay, so both answer will be acceptable. Okay, so it could be molar or premolar because we can see two cuts visible or two roots visible. Okay. Okay, which layer of the tooth is the hardest? Okay, so the hardest layer will be the outside layer, okay, which is the enamel, which protect our tooth. Okay. Okay, name one vitamin and one mineral needed to develop this layer. Okay, so to to have the enamel, so means we need to have a hard, strong layer to protect our tooth. Okay, so we will need vitamin D and the mineral of calcium. Okay, straightforward. Okay, next. A shortage of which food nutrient can result in deficiency, disease of scurvy? We know that it is vitamin C. Okay, so lack of vitamin C will cause the scurvy. Okay, next. Enzymes are involved in the process of seed germination. Okay, food stored in the seeds is often in the form of starch. Okay, so if we have the seed, okay, so we want it to grow. Okay, germination. So we have a storage of food in the seed. Okay, so it's in the form of starch. So name the enzyme to digest starch. Okay, so if we want to digest the starch, the enzyme that we need, it will be the amylase. Okay, so the product breaking down amylase. Okay, so we recall that here. Okay, wait. Okay, breaking down amylase. By amylase will be starch broken down by amylase to maltose. Okay, and then with maltase break down to glucose. Okay, so our final product, reducing sugar, which including maltose and glucose. Okay, two uses of this product in the germinating seeds. Okay, so we produce the sugar. So what we use the sugar for? Okay, uh, we can use it as an energy source to convert to cellulose to make the cell wall, to convert to materials for growth. Okay, so this glucose can also convert to amino acids and protein. Okay, yep. Okay, next. Two physical differences between starch and the end product of the digestion. Okay, so how is it different? Okay, um, okay, so how is it different? Starch and glucose. Okay, okay, so starch is large insoluble molecule. So maltose or glucose, they are smaller and soluble. Okay, straightforward. Okay, next. Okay, the process of germination cannot start until the seed has taken in water. State two reasons why water is needed for germination. So water is also very important. Okay, so we learned that enzymes are only active in water. Okay, so enzymes need water to work. Okay, and then cells become turgid, leading to expansion. Okay, next. Okay, so the diagram show a side view of the human abdomen. Okay, yeah. So we are familiar with the front view, which look like this. Okay, yeah. So this is the front view. Okay, yes. Okay, so the front view look like this. So from the side view, we can identify uh, the different parts as well. Okay, so no problem. Okay, complete and identify part A and B. Okay, so what will be A? Okay, so if we see carefully here, this part here is this. Okay, which we know is the esophagus. Okay, esophagus. Okay, so B. Okay, so it's corresponding to here. Okay, so which means it's the ileum or small intestine. Okay, so straightforward. Okay, so the name and function. So just now, part A, esophagus or gullet. Function, move food from mouth to stomach. Yeah, okay. So moving the food from the mouth to the stomach. Okay. Next, just now we mentioned ileum. Okay. Small intestine. Function, loss of function, digestion of maltose and peptides, absorption of product of digestion or water. Okay. So in the small intestine, we will complete all the final steps of the digestion and also absorb all the nutrients that we have digested. Okay. Next, the type of food digested in organ C. Okay, so C is we can see is corresponding to the stomach here. So the main food that is digested in the stomach will be protein. Okay, so we already learned that. Yes. Okay, so in the stomach, the main digestion is the protein. Okay. Okay, next. So we are given two type of food, lamb kebab and corn sausages, both good sources of protein. The nutritional content are shown. So lamb kebab and corn sausage. Okay, no problem. So now we want to state and explain two reasons why the corn sausages may be healthier than lamb kebab as a major item in the diet. Okay, so we'll take a look. Yeah, let us copy this and put here. Okay, yeah. Okay, so what can we comment about this? Okay, okay, first, um, less saturated fat. Okay, so we can see here, this corn sausage has less saturated fat, so it's less risk of heart disease. Okay, so we are saying that the corn sausage is better. Okay, so fiber. So we can see this corn sausage has more fiber. Okay, so it's less risk of constipation. Okay, next, calcium. Okay, this corn sausage is having more calcium, 42.5 versus 38.0. So it can help to maintain healthy bones, teeth, and to prevent rickets. Okay, so this is how we can analyze this data. Okay, next. Okay, uh, okay, hold on. Okay, next, what we can say about this. Lamb kebab contains more iron than corn sausage. Okay, iron. Okay, lamb kebab is more. Okay, suggest additional source of iron for a person eating corn sausages in their diet. Okay, so let's say they decide to eat the corn sausage. Okay, what else they can eat to get more iron? Okay, so we also have in the notes. Okay, so to get more iron, we can get from these food sources. Okay, red meat, liver, kidney, eggs, green vegetables, and so on. Okay, yeah. So this is what we can see. Okay, another red meat, liver, kidney, eggs, green vegetables, chocolate, and so on. Okay, next, state the function of iron in the body. Okay, so why iron is important? Is needed for formation of hemoglobin in the red blood cell. Okay. Yes. Okay. So needed for the formation of hemoglobin in the red blood cells. Okay. Outline the effects of deficiency of iron. Okay. We know that if we are lack of iron, it can lead to anemia. Okay. Yeah. Okay. Lead to anemia, which cause the tiredness and lack of energy because we cannot get enough oxygen, so we cannot produce enough energy. Okay, yeah. So this is done. Okay, so with this, we finish all the practice questions on the workbook. Okay, so yeah, so this is all done. Okay, yep. So this unit 7 is completely done. Hold on. Yes. Okay, so next we move on to chemistry. Okay, chemistry C5, chemistry unit 5. Okay, which is electrochemistry. Okay, electrochemistry. So this is our next topic here. Okay, electrochemistry. Okay, so let me open the document. Okay, so this is also quite a big topic. Okay. Yeah. Okay. So the notes I sent to you some time ago. So suppose you have it. Okay. Um okay, let's take a look. Okay, electrochemistry. What is the main point of the electrochemistry? Okay. So here we have some key terms. Okay, so we will also come to this later. Okay. So what it means by electrochemistry. So electrochemistry, the main thing we are looking at will be electrolysis. Okay. So basically it's chemistry involving electricity. Okay. Yeah. So what is electrolysis? We have a energy supply. Okay. So energy supply. Okay. Which which provide the electrical energy. Okay, so electrical energy, why we want this electrical energy? So our objective is to decompose the ionic compound like sodium chloride, something like that. Okay, or ionic compound that's dissolved in water by the passage of electric current. Okay, so decomposition means, okay, so example this sodium ion and the fluoride ion. Okay, decomposition means we want to return back to the element. Yeah, return back to the element. So that's our objective. Okay, so sometimes the element is more useful than the ion. So example, iron 3 plus, this is not useful for us, okay, because it's just the iron oxide is not useful for us. We want to return back to the iron metal or element that is more useful for us. Okay, so that's why we have this electrolysis. Okay, so so this is the electrolysis setup here. So we have the power supply. Okay, which could be just from the power grid or from batteries. Okay, and then we have electrolyte. Yeah, okay. So the liquid in the electrolysis is the electrolyte. Okay, so we can put it in the crucible if we need to melt it, or in a beaker, or if it's in room temperature. Okay, so electrolyte, and then we also have electrode. Yeah, we have two electrode. Okay, and then normally we will use the carbon electrode. Okay, so why we choose carbon? Carbon can conduct electricity. Okay, so that is the first point. And second point is inert. Okay, inert means it's not reactive. Okay, so it's not reactive, it does not react. Okay, so it does not react means it will not interfere with the chemical reaction here. So we want it to be inert. Okay, and then we have the anode and the cathode. Okay, so anode and cathode. Okay, so anode, we can see this battery here. Anode is the positive terminal, and then cathode is the negative terminal. Okay, so these are the main points. Okay, next. Okay, hold on. Okay, electrolytes. Um, so substance that conduct electricity can be divided into conductor and electrolyte. Okay, so we need to know the difference. Okay, difference between conductors and electrolytes. Okay, so conductors, they are solid. Electrolytes, they are liquid. Okay, so differences, conductors can conduct electricity, but they are not chemically changed by the electric current. Okay, so they do not take part in the chemical reaction. They become hot. Okay, and that example of conductor, all metallic elements and alloys, and also including graphite and graphene. Okay, yeah. And then particle responsible for conduction will be the electrons. Yeah, okay. The free electrons. Okay. So this is the metal. Okay. Okay, this is the metal, and then there are a lot of electrons, the sea of electrons. Okay. And then electrolytes is liquid. They can conduct electricity, but they will take part in the chemical reaction. Okay. So the products will be formed at the electrodes. Okay, so normally two types, molten ionic compound. So just the example sodium chloride. So we just melt it. Okay, we just melt it. So we have the sodium and chloride ions. Aqueous solutions means we dissolve in water. So we have the water molecule, and then we also have the sodium chloride. Okay, so that's the aqueous. And then the particles for conduction, they are the ions, the sodium ions and the chloride ions. So here will be the electrons. Okay. Hold on. Okay. So next, we'll look at the electrolyte. Okay. It must be in liquid state. Okay. So it is a liquid state. Okay. Solid ionic compound. So example, so let's say this is sodium chloride. Okay. So solid ionic compound, they cannot conduct electricity. Okay. Because the ions are held together in a giant ionic lattice. Okay. So they are fixed. Okay. So they are fixed in the lattice. They cannot move. Okay. Strong electrostatic attraction. Okay. So they cannot move. So they cannot conduct electricity. Okay. So we want to make it into electrolytes. Okay. So we want to make it into electrolytes. So there are two ways to do it. Okay. So let's take a look. Okay. So first way is melting. Okay. So melt the solid. Okay. So we can see this is molten sodium chloride. So inside we just only have sodium and chloride. That's all. Just sodium and chloride. Okay. So we need to melt it. It needs a large amount of energy because ionic compound, they have high melting point. Okay. But once we melt it, we have these moving ions that can conduct electricity. Okay. Next, dissolve in water. Okay. It also contains moving ions. Okay. So second way, we can dissolve in water. Okay. So now we have the ions. We have the sodium chloride, sodium ion and chloride ion. And then we also have the water molecules. Yeah, we have water molecules. And then we also have the water ions. Okay, so water is H2O, so it can produce hydrogen ions and hydroxide ions. Okay, so we have sodium ion, So here we only have sodium ion and chloride ions. So here we have sodium ion, chloride ion, and then we also have the ions coming from the water. Okay, hydrogen ion and hydroxide ion. Okay, so we can see the difference here. Okay, so molten is only sodium and chloride ions. We just melt it, no water. The solution, there will be water, which will produce another two ions. Okay, sodium ions, chloride ions, and also um, ions coming from the water, hydrogen ions and hydroxide ions. Okay, yes. So this is the difference between molten and solution. Okay, so both can be used as electrolytes, depend on the situation. Okay, next. Electrodes. Okay, so just now we saw the setup. Okay, the electrolysis setup. Okay. Okay, so let me just clear everything. Okay, and open again. Okay. Hold on. Okay. Yeah. Let me just copy this. Okay. Okay. And put here. Okay. Yep. Okay. So so we can see there are two electrodes. So the anode is from the positive terminal. Okay. Cathode is negative terminal. Okay. Connected to negative terminal. Okay. So now example, we have the positive ion and negative ion example. So let's say we have in here we have sodium ion, chloride ion, and then let's say this is solution. We have hydrogen ions and hydroxide ions. Okay, so this is the positive terminal. This is the negative terminal. The positive ion will be attracted to the negative terminal. Yeah. Okay. So positive ion attracted to negative terminal, and then negative ions will be attracted to the positive terminal. Okay. So that is the concept. So step one, the ions will be attracted to the terminal, and then reaction will happen. The chemical reaction will happen. Okay. Yeah. So positive ions will go to the cathode and then negative ions will go to the anode. Okay. So step two. Okay. So the products of the electrolysis will form at the electrodes. Okay. Okay. So the ions will come here. Okay. And then the reaction will happen and then it will produce the products. Okay. So products of electrolysis will form at the electrode. Okay. So what will happen? Okay, what kind of reaction will happen? The ions will lose their charge, okay? To form atoms or molecules, they are said to be discharged, okay? So, example, okay, at the cathode, so this negative, this is positive. So, example, at the cathode, it will attract the uh, hydrogen ion, which is positive. So, it will discharge. So, it will um, remove the charge. Okay, so this is plus one. How we can get how we can remove the charge? We will add negative charge. Okay, so now the charge is zero. Okay, so basically we have this hydrogen ion adding one electron, it becomes hydrogen zero. Okay, so at first This is hydrogen, no electron. So now it got one electron. Okay. So this is the discharge process. Okay. But normally hydrogen is present as a H2. Yeah, because H2 is the stable one with the octet. Okay, so normally it's H2, so which means we need to add. Okay, we need to have two together. Okay, so we need to balance the equation. Okay, so the H plus ions, they are reduced because, so this is what we say a reduction. Okay, so reduction happen here. Okay, so remember for electrochemistry, we always have a redox reaction happening. So we have reduction and oxidation happening. Okay, so we know reduction is when they gain electron, okay, and a decrease in the oxidation number. So these are the two conditions for reduction. Okay, at the anode, for example, we attract the negative ion. So this chloride, okay, it needs to discharge also. So chloride, okay, it goes to chlorine 0, okay. So -1 going to 0. So this chloride, okay, is like this. It got 8 outer electron, okay, -1. Okay, so it needs to return back to the chlorine 0. So now it will lose 1 electron, okay. Okay, so now it will lose 1 electron. We return back to the chlorine 0. Okay, so which means it will minus 1 electron here. Okay, but in chemistry, normally we don't write minus electron. We always write plus electron. So the negative electron will move to here. Okay, like this. Okay, so we know that in the real situation, it lost 1 electron. Supposed to be minus electron, but in chemistry, we don't write minus electron. We always write plus electron. Okay, so we will write like this. Okay, again, chlorine is always present as a Cl2. So which means we will make it like this. Okay, so we will balance the equation. Okay, so that's the concept. Okay, so here we are saying it is oxidation. Why? Oxidation means losing electron. So it's losing electron here. And then increase in oxidation number. Okay, we start with -1, the oxidation number. And then after we lost 1 electron, it becomes 0. Okay, yeah. So this one may be a little bit confusing, but we will come back to this again. Okay. What we might do is, okay, we will quickly go back to our topic before. Okay, maybe it's this one. Okay, we just quickly recall what it means by that. Okay. Yes, yes. Okay. So here, working out oxidation number. Okay. So just now, okay, our chloride ion is -1. Okay. Uh, okay. So here, if we have a charge of -2, the oxidation number will be -2. So the chloride is -1. So the oxidation number will be -1. Okay. So after we remove the electron, it become chlorine 0 because we return back to the element. Okay. Yeah. So if cannot remember, can come back to refer how we determine the oxidation number. And then another one is how we determine whether oxidation or reduction happen. Okay. So if reduction, we have 4 conditions. Okay. So anyone will do. Okay. Reduction means loss of oxygen. gain of hydrogen, gain of electrons, and decrease in the oxidation number. Okay. So for oxidation, what are the conditions for oxidation? Okay. So oxidation is gain of oxygen, loss of hydrogen, loss of electron, increase in oxidation number. Okay, so here we have losing electron, increase in oxidation number. Okay, lose electron, increase oxidation number. So means we have oxidation happening here. Okay, so we always have a redox reaction. We have reduction happening and also oxidation happening. Okay, yeah. So you can see this electrochemistry topic is kind of complicated. It's one of the hardest topic in the IGCSE, but once you understand it, you'll be okay. Yeah. So lots of detail need to remember as well. So now we will go through and look at all the different examples, okay? The different examples of electrolysis, okay? So we need to know all of them. Okay, so first example is the electrolysis of molten lead bromide, okay? Molten lead bromide. Okay, so what is going on here? Okay, hold on. Okay, okay, molten lead bromide. Okay, so this lead bromide is like this: PbBr2. Okay, so this is ionic compound. Okay, so this ionic compound. Okay, so electrolysis is only happen for ionic compound, not for covalent compound, only ionic compound. Okay, so what we do, we take this lead bromide. Okay, so we will melt it. Molten means we will melt it. So now we have the lead ions and the bromide ions. Okay, so now what happened? The bromide ions will come to this. So we have positive and negative electrode. So the bromide ions will come here, and then the lead ions will come here. Okay, so now the chemical reaction will happen. Okay, so the lead, okay, so it actually start here. Okay, so it start here. The bromide, okay, it will discharge. Discharge means it will remove the electron. Okay, so like this. So remove one electron, so we get bromide 0, and then we have electron here. Okay, because the bromine is always Br2, group 7 is always Br2, so we will balance like this. Okay, so you see, we produce some electrons here. So these electrons will go in the circuit. Yeah, so this electron will come here. Okay, yes. So this electron will come here. What happened? So now this bromide will take these electrons. Now it gain 2 electrons. So now it becomes lead 0. Okay, yeah. So big at first is 2 plus, gaining 2 electrons, it becomes lead 0. Okay, so we have product here, lead metal. Yeah, so we have the lead metal here, and then here we have the bromine gas. Yeah, the bromine gas produced here. Okay, so that's what happened. Okay, so we need to, for each reaction, we need to understand what happened and then what are the products. Okay, so this is quite a hard topic. Okay, next. Yeah, so at the high temperature, the so we will produce this bromine, lead metal and the bromine gas. So both product, they will vaporize because the temperature is too high. Okay, so this reaction must do it in the fume cupboard. Okay, so the toxic fume does not come out. Okay, next. So we need to know what are the products. So here will be bromine. And then we will observe the orange red vapor. So in the exam, sometimes it will ask, okay, what we observe, what we can see, okay? And then lead. So we will see a silvery gray metal produced here, okay? Next, electrolysis of molten binary compounds, okay? So molten binary ionic compound, they are electrolyzed. Okay, so we'll see some examples here. Yeah, okay. So what it means by binary, okay? So the non-metallic element will form at the positive electrode and the metallic element will form at the negative electrode, okay? Always. The metal, okay? So this is the cathode, okay? This is the anode. So we can see the metal will always form at the cathode. The non-metal will always form at the anode. Always like that. Okay, so we need to remember that. Why? Because the metal will be positive, it will be attract to the negative electrode, which is the cathode. So it will always form at the cathode. The non-metal, which is the bromide here, negative, it will always attract to positive. That's why the non-metal product is always formed at the anode. Okay, so this one need to remember. Okay, so we have some example. Okay, let's say we have lead bromide. Okay, Pb2 plus and bromide. Okay, so it will turn to bromine and lead metal. Okay, and then potassium iodide, potassium iodide. So it will turn to iodine, and then here it will return back to the potassium metal. So basically, we return back to the element, okay, before any electron transfer happen, okay. And then sodium chloride, okay. So now it will turn to chlorine and sodium metal, okay. Yep. Okay, so half ionic equation. So we can see that for the extended course, we need to know how to write the half ionic equation as well. Okay. So yes. So the non-metal is always react at the anode. Okay. And then the metal always react at the cathode. Okay. So okay, again, lead bromide. Okay. Potassium iodide. Okay. Sodium chloride. Okay. So we'll go through that. Okay, one by one. So for the bromide, okay, as I mentioned before, it will remove the charge. Okay. So bromine, if we go to the periodic table, is in group 7. Okay. Bromine is in group 7. So it has 7 outer electron. Yeah. Okay. So this, it has 7 outer electrons. So this is bromine 0. Okay. So once it react, normally it will receive 1 electron from the metal. Yeah, so normally it will receive 1 electron from the metal. So now it's got the octet. So now is -1. The charge is -1. Okay. So it's quite stable. Okay. So this Br minus is very stable. Okay. So it does not like to return back to Br0. No, because this is octet. It does not like to return back. That's why we need to provide energy. Okay. So that's why we always connect electricity. Yeah. Okay. So we need to provide energy because we are forcing it to return back to the element. Okay. So the Br negative is stable because it's octet. It does not like to return back to the element, but we are forcing it to return back to the element. So we need to provide energy here. Okay. Yes. Okay. So one by one. Okay. So this bromide ion is already octet. It's happy. It does not want to return back to the element, but in this electrolysis, we are forcing it to return. Yeah, okay. So we provide energy, we push it back. Okay, essentially that's what we are doing. So we are pushing it to remove the electron. We force it to remove the electron. Okay, so what we have is okay. So what we have is we have this Br negative. Okay, it's removing one electron, okay, to return back to Br0, okay? But I mentioned before, the electron, we don't write negative, we always write positive. So we have Br, and then like this, we move to the other side, it's positive electron, okay? But bromine is always Br2. Why? Because bromine is always Br2 because bromine is 6 outer electron. Yeah, okay. No, 7 outer electrons. Okay. So if we form the ionic compound, if we form the covalent compound to fulfill the octet, okay. Okay, in order to fulfill the octet, we must form Br2. Okay. So we must form Br2. So which means to balance the equation, we will do like this. Okay. So that's how we get this equation here. And then for iodine and chloride is exactly the same. You can see exactly the same. Why? Because they are all from group 7. Okay. So they are all from group 7. They have exactly the same properties. Okay. So each of them, okay, will be 2 electrons. It will form Br2, I2, Cl2. Okay. So it's exactly the same. Okay. How about lead? Okay. So what happened for lead? Okay. So lead. So Pb2 plus. Okay. So Pb2 plus, we want to return back to Pb0. Okay. So we need to add 2 electrons. Okay. So because this is 2 positive charge, we need to add 2 negative charge, which is coming from the electron to get the Pb0. So this one, we don't write the 0 here. It's fine, no problem. So if we don't write the 0, means the oxidation number is 0. Okay. So potassium and sodium is the same. Okay. So potassium and sodium, they are in group 1. Okay. So group 1 means they have 1 outer electron. Okay. So sodium is going to have 1 outer electron. And then if we give it a chance, it will lose the electron. Okay. So after it loses the electron, it's going to have the octet, which is very stable. Okay. So if we don't do anything, the sodium, it just want to stay as 1 plus because it is stable. Okay. It just wants to be sodium plus. But in electrolysis, again, we are forcing it back. We want it to return back to sodium 0. Okay. So we are forcing it back to sodium 0. Okay. So we provide energy. So we are forcing it to take back 1 electron. Okay. So it will plus 1 electron to get the sodium 0. Okay. Potassium is exactly the same. Okay. Because they are both in group 1. So that's how we do the half equations. Okay. Ionic half equations. So we need to know how to do that. Okay. So later we will have more examples. Okay. So just now we look at electrolysis of molten lead bromide. Okay, so this is the first example. So now we'll look at the second example, which is electrolysis of aluminum oxide. Okay, so this is very important industrial process. Very, very important. Okay, so because aluminium, okay, aluminium metal. Okay, so let me just quickly find a photo. Okay, um aluminium. Okay, yes. Okay. Uh, yep. Okay, so aluminium actually it looks like this. Okay, yes. Aluminium is a metal, okay, which is very, very useful. Okay. Ah, yes, yes. Okay. Yeah, we can take a look. Okay, so aluminium is actually very, very useful. Okay, sorry, this is not clear. Okay, let me just find another one. And okay. Ah, yes. Uses of aluminium. Okay. So yes, aluminium is very, very useful. This metal, okay. So we can use it for so many things. Okay. So building material, uh, drink cans, communication, space, environment, transportation, okay, energy, sports and leisure, okay. So aluminium, we can use it to make so many things, okay. So it's very, very useful material, okay. So that's why we have this example here because aluminium is very, very useful. But, okay, aluminium oxide, this is aluminium oxide, okay, that we can, let's say we go to the mountain, we get it, the aluminum oxide, it's look like this, okay. So it's not useful, okay. It's Al2O3 is not useful because it does not have this metallic, this metallic properties, okay. It's not useful. So we need to, this aluminium 3 plus, we need to return back to the aluminium metal. Okay, so this is the one that is having so many uses. Okay, so this one is not. Okay, the Al2O3 is not useful. So we want to return it back to the metal. So Al3 plus, we need to return back to the metal. Okay, so that's why we have this electrolysis of aluminium oxide. So our objective is to return back Al3 plus to Al0. So that is our main objective. Okay. But we also have a byproduct. The oxygen will return back to the oxygen gas, which is not what we want, but that is the byproduct. Our main thing is we want to get this aluminum metal. Yeah. Okay. So basically, this aluminum, we can get it extracted from this bauxite. Yeah, okay. So this is the bauxite there. Okay. So which is impure aluminum oxide. Yeah, okay. So maybe it got like 90% aluminum oxide, something like that. Okay. So the bauxite is first purified to get the Al2O3, the aluminum oxide. Then we will have the electrolysis. Okay. Yeah. So electrolysis has to be used because aluminum oxide is not reduced by carbon monoxide or other common reducing agent. Okay. So if we look back to here, I think maybe we have example. Okay, we don't. And it's okay. The main point here is actually we have another way to get from ion to metal. We have other ways. Okay, electrolysis is one way. So if we want to take aluminium 3 plus to aluminium metal, we can use electrolysis. Okay, but we have another method. It's called reduction. Okay, reduction by carbon. Okay, so this is another method. Okay, reduction by carbon, we can do it for iron 3 plus to iron 0. We can use reduction by carbon. Okay, but for aluminium, we cannot use reduction by carbon. This carbon monoxide cannot. Okay, the reason why we will learn later. In a later chapter, we will learn why. Okay, so this reduction by carbon is cheaper. It's a cheaper method. Okay, if we can do it, we will do it. Like iron, we will use reduction by carbon. Okay, but aluminium, we cannot use reduction by carbon. Okay, so we must use electrolysis, which is very expensive. Okay, very expensive. But we have no choice. That's why we always do aluminium recycle. Okay, aluminium recycle, like the aluminium cans that we use, we do it recycle because aluminium is expensive to uh to produce it. It's very expensive process. Okay, yeah, it's expensive due to high cost of electricity. So we need to produce provide so much energy for this reaction to happen. Okay, okay, so how it happened? Yeah, okay, so we'll take a look. Because aluminium is so useful, that's why we will study it in detail. Yeah, because it got so many uses. We'll study it in detail. Okay, um this process, how we get aluminum, how we get from Al 3 plus to Al 0. Okay, so yeah, so we're starting with the aluminum oxide. Okay, which has a very high melting point, 2071 degrees Celsius. Okay, so to melt, okay, so first we need to melt the aluminum oxide. We need large amount of energy, which is increasing the cost. Okay, but the scientists that come before us, they have a method. Okay, so what they do, they dissolve the aluminum oxide in this cryolite. Yeah, this cryolite is a very special compound. Okay, what does it do? Okay, so this cryolite, um, basically we can melt the aluminum oxide at lower temperature. So the electrolyte can be maintained at liquid state between 800 and 1000 degrees. Okay, so at first we need to get to 2071 degrees, which is very expensive. But now with this cryolite, we can do it 800 to 1000 degrees, which greatly reduce the energy cost. Okay. Another thing, this cryolite will improve the conductivity of the electrolyte. So which will help the reaction to go faster. Okay, so that's good. Okay, that's good. So now, what happened? How the reaction happened? Okay, it happened in this steel tank. Okay, so the reaction happened at here. Okay, so let me just copy everything here. Okay, so how the reaction happened? Okay. So we'll look at it step by step. Okay. Yep. Okay. So we need to like understand, okay, how it happened. Okay. So first we have this steel tank, okay, 4 meter wide, 1 meter deep, okay, 8 meter long. Okay. So a big tank. Okay. And then we have the carbon graphite will be the electrodes. Okay. Graphite electrodes. and then the anode will be carbon blocks. So we have anode is here, cathode. This is the cathode. This one, okay? It's just the lining of the steel tank. So this is the cathode, okay? Cathode. Okay, and then the reaction will happen. So the cathode is negative. So it will attract the aluminum to here, okay? So this one is positive. So it will attract the oxygen, okay? So now it will happen the reaction. Okay, so first, the oxygen will be discharged. Okay, so how it discharge? It will let go of electron. So we present like this. It will let go of 2 electrons. Yeah, okay. It will let go of 2 electrons to get to 0. Okay, but because oxygen is always O2, so now we need to double everything. So this become 4 and then this become 2. Yeah, so that's why we have this half equation here. So now it produces 4 electrons. So this 4 electron will go to the cathode. Yeah, so this cathode will get this electron. So it will get this electron. So it will take this electron and reduce to aluminum metal. So we have the second reaction here. So this is how it happened. So now once we have this aluminum form, the molten aluminum will collect at the bottom of the tank. Okay, will collect at the bottom of the tank and then we will take it out. Yeah, we will take it out. So now we collect the aluminum. So this is what we want. This is the key point there. All right. And then we also have a side reaction, which is this oxygen. So this oxygen is produced here. Lots and lots of oxygen is produced. Okay. So what happened? This oxygen, it produced at the anode, it will react with the carbon. Yeah. So basically this is carbon. So it will react with the carbon to form carbon dioxide. Yeah. So we will notice this carbon, it will become smaller and smaller because it react with the oxygen to form carbon dioxide. So the anodes will burn away. It will need to replace regularly. Okay. So basically, the cost of electricity will be the large expense. So normally, this aluminum, this factory, okay, it will be built at the place where cheap electricity is available. Okay, example, hydroelectric power. Okay, yeah. So next, we will move on to the next example. Okay, so just now we just looking at molten situation. Molten situation, we just melt. Okay, we just melt it to get the ions. Okay, so this is the molten situation. So next, we will look at the solution situation. Okay, so solution situation, we will going to have water, and then we're going to get this another 2 ions. We will get additional ions. Okay, so how it happened? So we'll look at this electrolysis of dilute sulfuric acid. Okay, so it happened at this Hoffman water meter. Okay, so this is the Hoffman uh water meter. Okay, so how it happened? Okay, so we'll take a look. Okay, so molten ionic compound produce non-metallic element at the anode and metallic element at the cathode. Okay, so as we mentioned before, the cathode is negative. Okay, cathode is negative. Okay, the anode is positive. So the anode will attract the non-metal and then it will turn to the non-metal product. So this one, the cathode is negative, it will produce, attract the positive metal and then it will produce the metal product. Okay, so always non-metallic is at the anode, the metallic will be at the cathode, always like this. But when we have aqueous solution, we can have other products. Okay, we can have other products. Example, we can get oxygen or halogen. Okay, and hydrogen and metal. Okay, so it depends on the situation. Okay, so the hydrogen and oxygen will be coming from the water. Okay, so basically it will become more complicated. Okay, you see here, this one we only have two products, aluminum and oxygen, only two products. But when water come into this situation, we will have other products. Okay, so that's the key point here. Okay, so this one, okay, so we'll move on first. Okay, so we will compare molten situation and aqueous situation. So this one example, this one we just have sodium and chloride example. So this one we will have aqueous situation, we will have sodium, chloride, and then we also have hydrogen ion and hydroxide ion that's coming from the water. Okay, so this will be more complicated. So this one, we only have two products. So this one will get the chlorine gas and then the sodium metal. Just like that. Okay. But here we can get oxygen gas. Okay. So the OH negative will turn to oxygen gas, or the chloride will turn to chlorine gas. Okay. So we can have two possible products. So this one, we can have H plus, it turns to hydrogen gas. Okay. Or like let's say we have copper 2 plus, we can turn to copper metal. Okay. So it is more complicated. So the molten situation is simple, only one product, one product. Okay. So this one, the solution situation is two product, two product. Okay. Only one of them will happen. Okay. So this a little bit complicated. So we will come to it later. We'll look at the example later. Okay. So now, yes. Okay. Different electrolyte. So this table is very important. Okay. So this will be all the things you need to know for the IGCSE. Okay. Electrolysis. What situation? Okay. What is the situation? Molten sodium chloride. Okay. And then what you expect to see at the electrode? What is the half equation? Okay. What happened at the anode? And then what happened at the cathode? Okay. So we need to know all of them. Okay. So all of this situation we need to know. So later we will come to this example one by one. Okay. So now the key point. Okay. So these are the key points that we need to know. Okay. Make sure you remember. Okay. If we have aqueous solution, okay, we will always produce hydrogen at the cathode. Always. Okay. Okay, so now I will explain why that is. Okay. Okay, let us compare. Okay. Okay, so let's say we have molten sodium chloride. Okay. And then we have solution of sodium chloride. Okay. So what's the difference there? Okay. Okay. So these are our electrodes. Okay. So this is anode Okay, so this is cathode. Okay, and then again, this is anode. Okay, this is cathode. Okay, so for the molten situation, we only have sodium plus and then chloride negative. Okay, so only two ions. Okay, so the solution situation, we will have sodium, chloride, and then we will have hydrogen ions and hydroxide ions that is coming from the water. Okay, so we have four ions here. Okay, now, so this sodium plus will come to here. Okay, okay, let me change another color. Okay. Okay, so the sodium plus will come to here, and then the chloride will come to here. So you will get the product, which is sodium metal, and then this one you get the product, which is chlorine gas. Okay, no problem. For here, you will have sodium plus and hydrogen plus. Okay, and then here you will have the negative chloride and the hydroxide. Okay, so now we have two things that will react, so only one of them will react. In this case, it will be hydrogen will react. Okay, we will get hydrogen gas. Okay, so now we can see here you get sodium, here you get hydrogen. That is the difference here. Okay, so that's the difference. Here you will get sodium, here you will get hydrogen. So that's why we say aqueous solution is always produce hydrogen at the cathode, always. Okay, so here the hydrogen will react the sodium. No, why? Because it depends on the reactivity series. So we see hydrogen is here. Okay, hydrogen is here, sodium is here. So sodium is high. Okay, so sodium is high. We look at sodium ion and hydrogen ion. Okay, so what it means by sodium ion is high reactivity. High reactivity. So this one, it may be for you a little bit complicated at this moment. You may not understand or cannot remember. It's okay. We will come back to this later. We'll come back again and again. So now I'm explaining here. You have sodium and hydrogen. Why the hydrogen react? Why not sodium? Because sodium is high. It's high reactivity. Means it loves to stay as a sodium ion. It does not like to go back to sodium metal. Okay, it's reactive. Means it does not like to return back to the sodium metal. Okay, the hydrogen is less reactive. Okay, compared to sodium, so it will be the one that return back to the element. So that is the concept here. Okay. Now coming to this anode, again you have two species here. Two species here. Which one will react? Okay. So we'll look at this aqueous solution containing positive ion of metal above hydrogen in the reactivity series. Hydrogen is produced at the cathode, not the metallic element. Okay, we are still here. So now, if we compare hydrogen and sodium, hydrogen will react because hydrogen is less reactive. Okay. How about if we have copper, silver, gold? Okay. So if we have copper, silver, gold, then this one will react. Okay. So that's what we're talking about here. So here, which one will react? So let's say we have copper here. Okay. So here now we have three options. If we have sodium and hydrogen, hydrogen will react. If we have hydrogen and copper, copper will react. So the one that is lower in the reactivity series, that is the one that will react. Okay, so that is the question. That is the point here. Okay, so that's why very reactive metal, okay, cannot be produced by electrolysis of aqueous solution. they can only be extracted by electrolysis using molten electrolyte. Okay, so like what I mentioned here, aluminium, okay, it must use electrolysis, okay, because it's higher than hydrogen here. So if we put hydrogen and aluminium together, hydrogen will react. So we cannot get aluminium. Okay, so that's the concept here. Okay. Electrolysis of copper sulfate aqueous solution. Okay, so here, we will come into this later, but I mentioned quickly. Okay, so here we have chloride and hydroxide. Which one will react? Okay, so it depends on the situation. If it is dilute, okay, dilute means the chloride amount is low, so this hydroxide will react to form oxygen, okay. But if we have concentrated solution, chloride is very high, okay. Chloride is very high, then chloride will react to form the chlorine gas, okay. So you can see this is very complicated. At different situation, you will get different product. So maybe first time you cannot like understand it easily. So you can come back to watch the video again, or we can discuss again later. So normally this one, mostly you will learn in year 11. Yeah, this is one of the most complicated topics. Okay. So first time, if you don't understand or don't remember, it's fine. You can ask question or you can come back to watch the video again. Okay. So now we will look at the next example. Okay. Yeah, we are almost done. Okay. So this one, okay, electrolysis of copper sulfate aqueous solution. Okay, so we are coming to the next example. Okay, so carbon and platinum electrodes. Okay, so normally we will use the um inert electrodes like carbon and platinum. Okay, and then the products will be copper at the cathode and oxygen at the anode. Okay, so we will try and understand what is going on here. Okay, we'll try and understand what's going on here. Okay, so here, this is negative, this is positive. So this is cathode, this is anode. Okay, so now we have copper sulfate. So we have 4 ions, copper 2 plus, and then we have sulfate. Okay, and then we also have from water, hydrogen ion and hydroxide. Okay, so now the positive ions will come to here. Okay, this is the negative electrode. So we have the copper 2 plus and then H plus. Okay, and then here we will have the negative ion. Okay, SO4, 2 negative, and then hydroxide. Okay, so which one will react? So this one, we choose between these two. Our answer is copper. Why? Because just now we mentioned the one that is lower in the reactivity series, it will react. Okay. So now this copper, it will reduce to copper metal. Okay. So this is our product here. So here we have 2 options. Okay. Sulfate and hydroxide. Which one will react? Okay, so this situation is always hydroxide because sulfate is very stable. Okay, most of the time it will not react. So this one, we will get oxygen gas. Okay, so we get oxygen gas and then we'll get copper metal here. Okay, so this is how we analyze the situation. Okay, yes. So now what we expect, the solution will gradually loses the blue color. Okay, so this copper ion is blue color. Okay, but once we turn to copper metal, it's turned to this brown color. Okay, brown orange metal. Okay, it will turn to this metal. So this copper ion is getting less and less. Okay, it's getting less and less. So we expect the blue color will turn to colorless. Okay, so sometimes the exam question will ask you what you see, what you observe, any color change. So you need to understand that in this case, the blue color will be less and less because this copper ion is constantly using up to produce this copper metal. Okay. Next. Yeah. So the concentration of the copper ion is decreasing. Okay. If if the anode is made of copper, yeah, what about, okay, just now, this anode is made of carbon. Okay, so it does not interfere with the reaction. It's inert. Okay, how about if we change this electrode, if we change to copper? Okay, so if we change to copper, so now we have three choice: sulfate, hydroxide, and copper metal. So in this case, the copper is the one that will react. So it will form copper 2 plus here. Okay, so you can see how complicated it is. Okay, so a lot of small details you need to remember. If you change to copper electrode, it will happen like this. So it will form copper 2 plus here. So what is actually the effect of this? You see, this one, we keep using up the copper 2 plus here. So the blue color will be less and less. Okay, but if we change this to copper electrode, so now we keep adding the copper ion. So here we are using, here we are adding. So in this case, the blue color, it stay the same. So that's the main point. Okay. So oxygen is not produced instead. The copper goes out into solution as positive ion. Okay. So the mass of the anode will decrease. Okay. So this copper will get smaller and smaller because it keeps on turning into copper ion. Okay. Yes. And then here we have the reverse reaction. Okay. The copper ion turn to copper metal. So here it will get bigger and bigger, this electrode. Okay. So the mass of cathode will gradually increase when fresh copper is deposited. Okay. And then in here, each one, the copper ion we use up is replaced here. So, okay, the blue color of the solution, it does not change. Okay, so that is the two situation. Okay, so these are the most complicated situation that we have so far. Okay, so if you not understand, not remember, it's okay. We will come back and repeat again. Okay, or you can come back to watch the video. Okay, so next, I think this is the okay, so this is the last part. Okay, finish this, we finish the class today. Okay, which is fuel cell. Okay, so fuel cell is another very useful setup. Okay, we use hydrogen fuel cell, we can use in electric car. Okay, so instead of using petrol, we'll use hydrogen as the fuel. Okay, so now we have the overall equation, which is like this. Okay, hydrogen plus oxygen, it turns to water. Okay, but in this case, the hydrogen does not undergo combustion like the petrol. It reacts with oxygen to produce electricity. Okay, yeah. So this is quite good because this petrol, it will produce carbon dioxide, which is a greenhouse gas. But this one, no pollution. Yeah, okay. So this is very, very good, no pollution. Okay, so this is the setup here. Okay, so we will put the hydrogen gas in here and then oxygen gas in here, and then it will undergo the reaction and then produce the water, and then at the same time it will produce electricity. Yeah, okay, so this is very good. Okay, but there are advantages and disadvantages. Okay. So advantages is more efficient, less energy loss because it's not doing combustion. Okay. Water is the only product. Okay. It does not produce carbon dioxide as a greenhouse gas. So it's environmental friendly. Okay. Disadvantage. Okay. It needs hydrogen, but hydrogen gas is very difficult to store. It's a gas and then it's explosive gas. Okay. Very difficult to store. And then it's low density. So we get lower mass, less energy will be produced. Okay. So the infrastructure, so we need to build up the infrastructure for this to work. It will cost a lot to develop. Yeah. Okay. So basically that is the concept here. Okay. Yeah. So we still have quite a bit to go. Yeah. So basically we will finish here. We will continue next time. Okay. So basically this is our progress here. Electrochemistry in progress. We will continue next time. So your mom told me tomorrow the class is cancelled. So tomorrow no class. So our next class will be on Thursday. Yeah, okay. So we'll be on Thursday. So yeah. So today the class is a lot of information. Maybe it's very confusing. It's okay. We will come back to this later and explain again, and then we'll have more um uh practice questions. Okay. Yeah. So if no other question, we will stop here and then continue on Thursday. Okay. So I will see you again on Thursday. So 8:30 a.m. So if you want to make it 8 a.m. If you want earlier, you just let me know. Okay. Otherwise, we start at the usual time of 8:30. Okay. So if no other question, we will stop here. All right. Okay. Thank you. Bye bye. Bye bye.